This conference will now be recorded.
Good evening. Good evening. Uh, do you have any doubts regarding the last class, Mr. Tilly? Mr. Tilly? Okay.
No doubt.
Yeah. Good evening. And we are now proceeding with the data types. We have seen already local data type, that is nothing but auto. These are storage classes which I am coming to explain. Okay. That is when we write a statement like int x is equal to 10, it means that we have an integer type and the variable is of integer type, and we are defining that variable or initializing the variable to 1. Okay. Within any function is encapsulated within curly braces. Okay. This way also we can do, as we know, that is first declaration and then definition. Yeah. So it means that we allocate the compiler for a normal Turbo C compiler allocates 2 bytes of data, 2 bytes of memory. Okay, this is nothing but auto. Okay, before going into storage classes, we will go for data types. One is small discussion about data types. Okay, this is 2 bytes of data, 2 bytes of data with signature in it, that is sign in it, that is it can indicate plus as well as minus. For example, minus 67 can be also, we can store in this memory, as well as plus 67 also we can store. Okay. The range of this is like, that is, we have, if it is 2 bytes of data, we can show it like this. This is 16 bits, that is 2 bytes of data, while the MSB, this is most significant bit, is nothing but this, it will represent whether it is plus or minus. Okay, if it is 0, it is plus, if it is 1, that is minus. Suppose we have 67 year data, this is a decimal form. This MSB will be indicating the signature, that is plus or minus. Remaining that bits are used to indicate this decimal data. Okay, so this decimal will be converted into binary format and then stored in this space only, that is 15 bits. Okay, and so these 15 bits can represent a, can be used to represent the digits from decimal digits from, that is minus, including the MSB 32768 to plus 32767. if if our data representation requires more range, that is we want to represent beyond this data, That is, if you want to define a memory more than this data or number or data, then we need to extend this memory, that is 16 bits of memory, to next level, that is 4 bytes, that is 32 bits. Okay? And so to do that, we add a keyword long. Okay. One more method is that suppose if our data doesn't require negative signature, that is negative sign, then we can use this bit also to represent, so that this bit also can be used to represent the number. Okay, in that case, we can expand it to the range of 0 to 65535. So to do that, we have to add keyword unsigned. Okay, we can also, if we still further required, we can extend it like long. If we need further extension, or say that we want 8 bytes of data, we can further extending it as long. Okay, so similarly we can do it for float. Okay, but for character, the negative is not required, and so usually we go for character representation as unsigned. Usually it is not required. So if for character, the default data byte is only 1 byte. For float, its default is 4 bytes. Okay. The memory which is allocated to each and every data type is depends upon the compiler. For certain compiler it can be 2 bytes, for certain compiler it could be 4 bytes for integer itself. And so this can be found by using the size of definition, size of function. This can give the detail what is the size. This can give us the data what is the size of x. Here it is. If it is float, we have to change the data type and then we can find it out. Okay, otherwise the elf will also indicate that they give that information. Okay, if we want only 1 byte instead of 2 bytes, if we want 1 byte, then we can simply go for short. Since the memory usage is very important when we run in this type of program in very smaller chips for embedded applications and all, memory usage is very critical. Okay, so these data types are useful, and accordingly the representation here also will vary. Okay, this is, if we have unsigned, it is u. If we add long to this, it is lu. If we add one more long to it, it is llu. Okay, like this it varies for each and every type. For signed it is d only, and so we need not worry. If we have short, then we have to add it as h. Okay, for signed indication it is d only, since we have, for normal integer is only signed indication, default is signed. So the when we declare a variable, memory will not be initialized, a memory will not be allocated. Only when we define a variable, this memory will be allocated in the stack. Okay, and how we are going to use this memory within a function, since within a function it is utilized, and how it is to be utilized, when, what is the scope of this memory, what is the lifetime of this memory is also to be given. Since in a lengthy program, every time we don't require memory to be available for a particular variable. It can be, it's what can be eliminated. Since when we in a program we have seen that we are using multiple functions, user defined functions also. Once the user defined function is executes its job, it need not be given with the resources. Resource here it is nothing but the memory. Okay, that these resources can be utilized for some other functions or some other methods. Okay, and so when, if you say this itself is a program, say some xyz function, once this exit function is job is completed, this x variable memory can be relieved, and it can be used for some other functions. It means it can be relieved so that it be automatically used for some other functions. And so accordingly, the storage classes, that is how this memory is stored in the program or utilized in the when the program is executed, is also defined. There are four storage classes: auto, and then we have register, then we have static, and then extern. The default type is auto. Whatever we have seen till these things are auto only. If you want to explicitly mention also, you can do it, and its scope is only within the any function. If it is within the, if you indicate it in the main function, it is within the main function. Okay, if if a if an integer is declared outside the function, that is in openly outside main also, then this is global, that is nothing but extern. If you don't mention also, it's okay. But if you mention it as extern, then this variable is available across different files. That is, in a larger program, you will have multiple files of compilable program. Okay, and so when you indicate this global variable in a one file, this, and indicate with extern, then it is available to other files also, this variable, and it is global. It dies only when the program is stops executing. And other one is register. Register is used whenever we require a variable to be fixed. That is, if it is initial, it's only once only initialized, and it can be changed by anybody. Okay, then it is useful. That is, if I say, if this register is usually stored in the memory of the CPU itself, that is, we can say cache memory. Okay, or otherwise within the processor memory. That is, when we want this data will not be altered by anybody, and it is required for any function. Okay, it can be defined inside a function or outside a function. If it is outside a function, it will be global, but but it is used for where count is there. That is, we want to in a loop, we are doing an average of somebody, some numbers of some populations, or we can say in a school we are taking an average of every class room. Then count is required. Count is, we are fixing some, the strength of the class is a count. The count is fixed. Okay, and so we don't change that count usually. In that case, register can be used. That is, wherever we are accessing this memory very frequently, whenever we are accessing this memory frequently, then this is required. Okay, and this register value, in a practical case, it is allowed to change. If in a program, if you want to change, you can change that also. Okay, simple. Any for loop, we are initializing I is equal to some 0, and we are checking with the strength, that is population, and then we are incrementing it in a loop. Okay, this I can be declared as a register. Okay, this is the function of it. And then next one is, we are going for static. Okay, static default value, when you initialize, like in the register, if you register, this declaration is done, default value of I will be 0. It will be automatically initialized to 0, while in a auto or normal default one, this I will be random number, that is junk number, initialized to junk number. Okay, we may append with this auto, may not be required. Default it is auto. And static, if you initialize any variable, if you declare any variable, it will be initialized to 0 by default. And what is the thing is, this is this this is usually used in a global case only, but otherwise also we can declare it anywhere inside a function also. Okay, but in practice we do for only global. But if you declare within a function, it is local to that function. Similarly, register is also local to function. If it is declared inside a function, it is local. Okay? And it is, it is local to any function, but its value will not change if it is if the function execute out of this function also. If the execution comes out of this function also, its value will not change. We will see a sample for that also shortly. That is, its lifetime will be available. This value, once any change is made to this value, this variable, it is available till the death of the program. While in the auto case and in the register case, if it is initialized within the variable, within the function, if it is declared within the function, its value, its lifetime of that value will be available only till that function execution is available. Okay, while extern is, it's similar to global. It is globally, it's available. If a x value is changed in one function, it reflects that value across any function. and its lifetime is also till the death of the program. This is a small program. T is tab space. Okay.
Could you clarify the for loop?
Pardon?
Um, could you clarify what's going on with the for loop? It says I equals
I'm
one,
not.
I equals count, I plus plus.
Yes.
Could you
What you want in
could
that?
you is it supposed to say I equals count?
I is equal to. Oh yeah, we have to initialize it. You mean to that, no?
Okay. Okay.
Isn't it? Right?
And then should I be uh less than equal to count?
I equal to.
I equals to count. Okay.
No, I'm initializing count is equal to 5, and I'm cross checking when I okay decision. Yeah, less than or equal. Now it is correct.
Okay. Okay. Thank you.
Hmm. Are you able to understand this program now? Yeah. Now we'll include the free spaces and see wherever it is required. Now it will be clear. The integer value is 962. That is integer value is 962. 1 minute. Here I'll edit it so that See, integer value I is 970. That is random number. Count we have given as 5. The value of I in function increment is 1. Okay. While in global I we have initialized 100. And so value of I in function increment is 1, 2, 3, 4, 5. But it has not considered the global I. It has considered the local I. And so the I in the variable which is declared locally takes priority when compared to the variable which is globally declared. Okay, this is what we are seeing here. And the we have taken the count variable as registered. That is, when the here it is, since it's 5 only, it does not have any significance. But when we go for a count in a larger number, it plays a significance, since this count variable needs to be regularly accessed from the stack of the memory in the program, which can delay the program execution. And so to do that operation, when the count variable needs to be fastly accessed. When we declare it as a register, it will be stored locally in the processor memory itself, direct memory itself. And so the faster accession of the data of the count variable will be done. And so the program execution will be faster. But this count variable practically will be will be available, will takes its space in the processor memory only when the space is available. Otherwise it will switch to auto mode only, that is default mode. And so now we will see the uh, case of static, how the variable of a static behaves. So now we will have one more. Since it is local to the function, I am declaring it in the increment only. If I am declaring in the main static variable, we cannot access in increment function. You see, we have run the function 2 times. Here we are able to see the junk value same I and count value 5 and count of j. You see, first it was 0, that is by default it is initialized, we didn't initialize in the program, and so it is j is initialized to 0 while I was initialized by junk number. And then we are call the function with for the I in the loop, and 1 2 3 4 5 is the it is incremented, while j, since it was initialized as 0, it was by default it has gone up to 4, which is a static variable, and again it has come out of the program. Again we have incremented, we have called the increment loop from the main program itself, while I has again repeated the value, since it is local to the, both are local to the function, but I will die once the function is exits, while the life of the j variable will be existing till the program death. So you see the j is now initialized, is having an initialization of 4, and so when it is incremented it has gone to 5. And finally we are seeing the value of the main function is 100, which is global variable. Did you got the difference now? Do you have any doubts till now, or you want to rerun the program? You want to see the output once again? Shall we proceed to arrays? So we'll go for arrays now. We will be seeing only single dimensional array, and it will be, today we'll see the introduction on it. Array is nothing but a collection of same set of variables, that is variables of same data type in collected together. Suppose we are having an n number of students or n number of employees in a company, and we are having a, we need to take the age input of the every employee. That is, if you are having a 2000 employees, we need to take the age of the 2000 employees. And so instead of storing each and every employees under different variable, we can store in one variable itself. And condition is that the variable will be having a multiple sets of subsets of this data type again, and this data type should be similar. That is, if we have integer variable, we say a, so here it is single dimension, that is it can store only one value. Suppose we are indicating it as 2000. That is 2000 integer will be created. That is what we can say in the memory. We are seeing 30,000 is the memory space address. That is 30,000 to 3001. It is 2 bytes. Okay, it takes 2 bytes. This is the address of the memory, and it is 30,000 is one 8-byte data, one 8-bit memory, and 30,001 is another 1-byte memory. So collectively 2 bytes of data it can store. So int a, if I say, it is 2 bytes. Suppose if we want to store 2000 data, then it will be going as 30,000 to 30,003 up to 30,000, 31,009, like this. 31,000 like this. Okay, that is 2000 into 2, sorry, 3, 33,998. That is 4,000 bytes of data, bytes of memory will be utilized here. That is this is for first employee. This memory register will be allocated for the second employee. So we have 2000 data can be stored under single variable, like a of 0 is equal to 23, a of 1 is equal to 34. These are ages. Okay, here it is a whole number. So similarly up to a of is equal to 56. Like this also we can initialize the variable, or otherwise we can initialize it as like this also we can initialize. Otherwise we can initialize it as, sorry, it will be 4. Okay, we have 4 variables alone, only 4, we can say 4 elements only, like this. Otherwise also we can initialize like this. These two formats are acceptable. Okay, that is, in the memory we will be having 2000 into 2 bytes of data, that will be continuous. And so when we do a plus plus, we access the next memory directly. That is, we are incrementing the element count only in this. Okay, if the default, if you say a, it is a of 0. If we increment with a plus plus, it is a of 1. And if you increment with once again, it is a of 2. So we will see a small program. array value 1, array value 2, 3, 4, 5. So this is how we will be accessing it. Similarly, if you want a user to feed the data, we can use scan function also. Okay, array and pointers has lot of relationships with each other, and it's the next level of discussion. I think uh, for single dimension we can close the array at this point. um, in fact, the address also we will try to show here once how the address is. For address, we should indicate it as unsigned, since if you give signed data, then format conversion will take place. An address is always an unsigned value, and so we should use U only here. If you use D, you will not get proper address data. You see how sequentially the memory is allocated for the arrays. So you can one more addition we will do. Now, now see, we are accessing here the second set of array, that is with address. When we give address plus plus, then not the increment is for 2 bytes of data, since address is integer. So 2 bytes of data will be incremented and value at that address will be taken into count. So you see here, you get clarity. So this plus plus increases by one variable type memory length, as we have seen here. This is one set of memory. So when we increment, the value at this set will be taken into count. Any doubt so far? Shall we call it as a day? And in next class, we will see about strings. Actually, we can discuss more on functions, but for beginning, this is sufficient. If you have any doubts, you can ask. And in next class, by strings, that will be last class for us. If you want, then we can. If you have any doubts, we can extend for one more session. Okay. Thank you.